to give a slightly different view of what we're looking at. And as a reminder, the angular momentum vector, which is what we're considering here, points perpendicular to the way something is spinning. So that tells us which way it's spinning in space. So this is looking at a case where now we have L equals 2, and so we can have 5 different m sub L values, right? So we can have, we can have m equals positive, or we'll start with the negatives. -2, -1, 0, +1, +2. So 5 possibilities, or a degeneracy of 5. And what's different about these 5 possibilities is which way, which direction it's spinning. The direction is quantized. That's kind of the weird thing here, right? And this is, again, quantum mechanics weirdness showing up again. Our hydrogen atom, the electron spinning around, can only spin around in specific, what we call orbitals, right, that you're familiar with. And this was what I was trying to draw in the previous video, but this representation is a little bit clearer to see. So what we know how long this arrow is right here, right? And this is given by our absolute value of L, which again was equal to the square root of L times L plus 1 times h bar. And the other thing we know is how far this points along the z-axis. And so that's represented here by these arrows, right? And those are different for each of our different m quantum numbers. So we have these 5 different possibilities represented on this plot. So this cone kind of pointing down here, this is our -2, m equals -2. The cone pointed here is our negative h bar. Here's m equals 0, +1, +2. And so that's represented by these different possibilities of these sort of cones of possibilities. So we don't know where exactly along these cones the angular momentum is pointed, but we do know it's pointed along one of these directions. Somewhere along, so for example, if we have the m equals 2 wave function, we know the angular momentum is contained in this, the direction it's pointing is contained in this circle that's represented here. And that's due to the fact that we know the LZ value, because the spherical harmonics are eigenfunctions of the LZ operator. So hopefully this clarifies things a little bit. If not, I'm happy to talk to you. This is a very confusing concept. But what's important here is to understand that we have this degeneracy happening. And this is why we have, for example, 3 different p orbitals that all have the same energy, px, py, pz, and they point in different directions, because the angular momentum of the electrons points in specific directions due to these sort of properties that we're considering here.